Now the salvage value would bring in some money. Pump A has an annual value to you of $600 times the over 6% 4 years. In other words, it has the salvage value has the same value as receiving $137.16 a year would be the same as getting $600 back at the end of 4 years. Pump B doesn't have any salvage value. The maintenance cost. Well, Pump A costs $360 a year. We don't have to do anything with it. It's already an annual cost. Pump B doesn't have any. And this is what makes it needed to be turned into yearly costs. Pump A costs $1.10 times, and it's going to run X hours a year. Whereas Pump B costs this much times however many hours it runs per year. So what I'm going to do is set the costs of the two alternative pumps equal to each other and solve for the value of X that would be the break-even point, the point below which I ought to buy the initially cheap pump, and the number of hours beyond which I ought to buy the initially expensive pump. And I'll go to my foreman and I'll say, how many hours a year is it going to take on that job to dewater that place? And he says, well, I'll probably run about 1,000 hours a year. And I say, I know which pump to buy. Alright, so I set Pump A's annual equivalent cost to Pump B's annual equivalent cost. And I get it annually has cost me, by paying $1,800, it has cost me $519 each year for that $1,800 expense. However, because I get some money back at the end, it is saving me $137 a year. Plus, to run the pump costs me $360 a year. Plus, it costs me another $1.10 for power every time I run the pump an hour. So this is basically the power cost on the pump. This one being very efficient, only costs $1.10 an hour. This one has got a little bitty motor or something, it's not very efficient, costs $2.35 an hour. Same way for Pump B. Put $158 due to the initial cost. I don't take off any due to the salvage recovery. I don't put any maintenance because there isn't any. It's a sealed unit, but that's why it doesn't have any salvage value either, because you can't fix the seals. Once it's dead, it's dead. Plus $2.30 times X. That would be $230. Solve for X out of that equation, you get the break-even point of 486 hours a year. Below which, pick one pump. Above which, pick the other pump. If you have a question in your mind, you say, well, I see the point, but I don't know which one is which. If the if the foreman says this pump's going to run 400 hours a year, then just come up to either one of these. Put this minus this plus 400 times this. And then come over here and say this minus this plus 2.30 times 400 and see which is the cheaper pump, because that's the annual equivalent cost, and pick that pump as the answer. Alright. Now, a second use of this break-even analysis is to determine at what level a manufacturing plant might operate in order to break even, considering its fixed and variable costs and the profit. And that sounds a little more like what the quiz might have on it, because he states that's what the equation is used for, although it's also used for the other thing. For example, a company is trying to determine at what level they must operate their plant just to break even. Fixed costs, $7,500 a month. That's just because you got to pay the wages, you got to pay the electricity, you got to pay the interest on the debt due to the building. Those payments have to be made if you don't even make one computer. Now then, their variable costs, they cost them $3 a unit to make. The way computers are today, that may be all it costs to make a computer. $3 per unit. They expect to make $10 per unit if they sell any. So they plot the fixed cost of $7,500. On top of that, they plot the variable costs. The variable costs starting here, raising up. And then you can plot the income. The income starts at 0, because if you don't make any, you don't get any profit or any income. And that line, where these two lines cross, where the cost equals the profits, then that's the break-even point. Above that point, you will make profit. Below that point, you'll have a loss. In our case, we set costs equal to benefit. Costs were $7,500 plus 3 times for every one you make. That was equal to the benefits is 10 times every one you make, and about 1,070 units just to break even. Now, payback period. A payback period is commonly defined as how long it takes you to recover an initial investment from the cash flow that you get out of that investment. It could include the effect of interest. A lot of times people don't say that. They just say, look, if we put $10,000 in this, we'll have our money back in 3 years. Pretty much ignoring the fact that the money you got back wasn't really worth as much. But, you know, that's a ballpark number of what they would call the payback period. If the problem on the exam says, and the interest rate is 6%, then he obviously wants you to include the effect of interest. If he just says, what's the payback period on something, for instance, maybe like this one right here. If I didn't give you an interest rate, well, here would be the payback period right here. 2440, would you get your money back here? Admittedly, your money wouldn't be worth as much. Someone else would have been using it for 4 years while you had to drive your old car instead of getting a nice new car. But that would be the payback period, not thinking about interest. Now, assuming the effect of interest is to be included, find the payback period for the following investment, assuming an interest rate of 6%. So, at the end of the 0th year, we're $10,000 in the hole. For year 1, we get a present value back. Well, the guy didn't pay us anything, so we don't get any present value back for that. For the end of year 2, we would actually have some present value. In other words, I can count on some present value by knowing that at the end of the 2nd year I'll get $2,000. It won't be worth $2,000 to me, so I'm going to have to bring the $2,000 back to what it's worth to me back at the point I'm considering that decision. The $2,000 is a future value. The future values, so you know which column to use, you multiply times P over F. F cancels F, leaving you with the present value of this money, $1,780. At the end of the 3rd year, you do the same thing. You have $4,000, except it's now 3 years away, so it's even less valuable. And then you get another $4,000. Same $4,000, but you'll notice being 4 years away, it's worth a couple $100 even less than the previous year's payment. And I can find out how much present value each of these numbers would give me back at the present. So if you'll add the present values year by year, in other words, add the $1,780 that we had first, and then add the $33,580, and then add the $31,068, and then add the $1,696. You find out at that time you'll have your $10,000 back. So that's what you would call the payback period. That includes the effect of interest and the fact somebody else was enjoying our money instead of me. And again, if the quiz problem doesn't give an interest rate, they're using the more common definition of payback period, and they're just the way we did it before. Inflation. Next topic in the FE review manual. The reference manual uses the equation D is equal to I plus F plus I plus F. Where they got that from, I don't know. I mean, I know where they got the equation, but I don't see it in any other economics books. Most of them, they call this I sub C for the combined rate. They call this, let me call that COM. This is I sub real, or something to tell you that that's the real, you really made money with this. And they do seem to call this for inflation, I for inflation. But regardless, what you got is what you're going to get to take in on the quiz, so you're going to have to get used to that that's the combined interest rate. It includes the effect of real and inflation effects. Now that D is the stated interest rate paid by the bank, or paid on the bond, or stated by the lender. In other words, that's the rate that I'm willing to give you some money. And I'm no fool. I know that that rate has to be big enough to cover inflation, and it has to be big enough to give me some money, or I'm not loaning you my money. It's the combined interest rate. For the lender, it combines the real rate of return, with which he really makes some money, and it includes the inflation rate, in which he doesn't do anything but lose money. You would probably also call that the market rate, because that's usually what the market charges for money. F is the inflation rate. I is the real interest rate. And he tells you what these terms are. It's just, to me, it took me a while to realize what they were, even when he told me what they are. That's another indication you really need to get in. Don't use your economics books for reviewing for this quiz. Use the reference manual, so you'll be very familiar with all these terms on every page. Here's an example. What is the actual present value to me of a bond which pays $6,000 a year at the end of each year for 10 years, and the purchase price was $20,000 at the end of the 10th year? Assume that I could get 6% interest on my money somewhere else. And so that's the minimum acceptable rate of return to me, and that's what I would calculate what this bond. This doesn't look much like a bond if it pays $6,000 a year, because it's paying almost a third of its value each year. That's a pretty good bond, and it'd be worth a lot to me. Still good for computation purposes. All right, here's the present value of such a bond. First, it has a value because it has an annual payout to me of $6,000 each year. Plus, it has a value to me because I'll get some money at the end of 10 years. The amount of money it gives me each year is 6. The amount of money it gives me at the end of 10 is 20. And therefore, to change an annuity or an annual amount into a present value times P over A future value times P over F, I calculate that bond, I would pay $55,000 for it, but no more. That's the value of the bond to me. Now that's assuming that there is no inflation rate. It doesn't say there's no inflation, but it doesn't say there is either in the problem. So I guess I have to say inflation is 0. Now then, what is the value of the bond to me if the inflation rate I anticipate will be 4%? How would that influence the value of the bond to me? Well, first off, I realize the dollars I'm getting back with don't have the same purchasing power. They don't have the same value. I still want a true rate of 6%. And so I'm not willing to pay as much for the bond. What is its value for me? A, B, C, D, E. A, B, C, D, D. Interesting. E. All right. What I would use is a combined rate. I'd say I really want 6%. And the inflation rate is 4%. And there's going to be inflation on the interest to boot. So I add another term, I times F. And that means that the true value of that bond must be computed on the combined interest rate, 10.24%. Now, unfortunately, 10.24% is not in the table, so let's just get a quick and dirty answer. Let's just assume it came out 10%, not too far off. That way I can use the tables. The present value of the bond is the string of annual amounts for 10 years plus the final payback at the 10th year. Look those numbers up, we get $44,758. There's that answer right there. And that bothers me a little bit because I know I'm not using the right rate. I shouldn't be getting that close. I'll bet you that when you put in a little more than 10%, you're going to be worth a little less to you, and so A is the answer. And I'd probably check A and go. But we got all the time in the world. Nobody's wife wishes they were home to help her cook supper, so let's check it. It's not hard to check because he gave us one of the potential, because we know the rate. We just can't use the tables. We have to plug in the P over AIN factor. It's listed in the book. The P over FIN factor, it's listed in the book. And we simply crank out the numbers, and it turns out that it's worth $44,034 to us. Another example, bank lends you $10,000 today, going to be repaid in a lump sum at the end of 10 years at a combined market stated bank won't loan you money otherwise interest rate of 10%. And that's the combined rate. I mean, he's not going to say I'll loan you money at 10% if the inflation rate's 10%. He knows better now. He'll just sit on his money. Compounded annually. So make sure you understand this is the combination with the bank hopes to gain. Plus the influence of inflation. If the rate of inflation is 8%, what is his true rate of return and how much money will they really make? I think we've discussed that enough. So let's see what the bank's real rate of return. You can read that and see if there's something different there. I don't think so. First off, the combined rate can be solved for because the book gives me the combined rate is I plus F plus I times F. Looks like F if, but that's I times F. So we can solve for the real interest rate the bank is going to get. The real interest rate, if you just solve for I out of this equation, you get D minus F over 1 plus F. Well, we know the combined rate, the stated rate, the market rate is 10%, minus the inflation rate is 8%, divided by 1 plus the inflation rate is 1.85%. So that's how much money they'll really make. You want to know how much they really make, you just drop it in the equation and use the really make interest rate, and you get $12,000. They loaned you $10,000, so taking back out what they loaned you in the first place, they really make $2,011. And the last thing in the book, yay, I hear you. The last thing in the reference manual is a benefit cost analysis. What it does, it tries to see if, this is usually used on public works projects, and civil engineering projects are very prone to use this method. They want to see if the benefits exceed the costs. If they do, then they figure they came out ahead and they can settle you into funding it with taxes. So if benefits are greater than costs, or if the ratio of benefits to costs is greater than 1, then you would assume that that project is a good project and should be done. You can either do that by computing either the present worth of the benefits. I mean, sometimes it's hard to compare benefits with costs because they appear at different times in the life of the project. Probably costs appear up front. Probably benefits occur way down the road, but maybe many times way down the road. So you either calculate the present worth of the benefits and compare them with the present worth of the costs, or you compare the annual worth of the benefits with the annual worth of the costs. Here's an example. You're considering a project wherein a small airfield is to be built. Land will cost you $350,000 today. Construction costs will be $800,000 today. Annual maintenance will be $25,000, but the first one will be due at the end of the year and every year thereafter. Annual benefits, on the other hand, we feel that because people won't have to drive as far, and because planes will come in here and the place will be easier to get to, and because more hamburgers will be sold, is $250,000 per year. Determine the benefit cost ratio, assuming that money is worth 6%, and the airfield is going to be good for 20 years, at which time we'll have to either tear it down or build a new one or enlarge it or something. We're worried about it then. Here are your present costs of your benefits. The present cost of the benefits is the only benefit you get is $250,000 a year times P over A. Why P over A? Because this $250,000 was an annual amount. A cancels A, leaving you with P at 6% for 20 years. Man, I'm getting good at this. I can do that. It's worth $2 million. Present value of the costs. Well, the costs, bang, $350,000 out of my pocket. Bang, $800,000 out of my pocket. And then this thing here comes out of my pocket, but it comes out later in life, in which case it's not quite so painful. And so I bring this back to its present worth at $25,000, an annuity at 6% for 20 years. Add these three numbers up. Go look at it in the book for me if you would. Multiply it times 25, add it to that times that. I forgot to do it. Comes out $1.4 million. Therefore, the ratio of benefits to cost, there's the benefits, there's the cost, greater than 1. Project should be considered. Other projects may be considered. Other projects may be better projects, and they may have higher benefit to cost ratios. All right, that's everything in the book. If you have any questions on that, we have a help session coming up. I believe it's next Monday, or one of the Mondays. I'll be glad to answer any questions you have then. I wish you good luck on the exam. I don't think you need luck. If you've been coming to these, I've been listening to them right along with you. I usually run the camera. Man, I've learned a lot of chemistry, and I've learned a lot of materials. I didn't know those little atoms went, I thought they went round and round. They don't go round and round, and I can work a bunch of problems that I could never work before, and I don't know very much about that subject. But you couldn't help but pick up 15 or 20 points just by listening to this stuff and learning just a little bit about how it works, even if you've never had that subject in your career.